Good day, everybody. So we are here today with the second episode of the Battery Metal series. Today I have with me Tom Revy. Hi, Tom. How are you?
Good, thank you. And yourself?
Not too bad. I think we have a few hours difference today. You're finishing your day and I'm starting mine.
Absolutely. And it's Friday.
It's Friday, correct, as well. So thanks, Tom, for being with me on a Friday evening. I appreciate it a lot.
No problem.
A quick introduction about Tom. Tom is the managing director for Evion Group. Mr. Revy holds more than 30 years of experience within the resources industry. And he has got experience with both corporate and project development. He's a specialist in that area. And he has worked internationally extensively within the mining sector. Tom, Evion today is a vertically integrated graphite developer. Tell us a little bit more about Evion Group.
Well, Evion Group was previously known as Black Earth Minerals. It's a company that was founded back in 2017. And its sheer purpose and strategy was to become a material player in the graphite supply chain, in the global supply chain. We didn't just want to be a miner, we wanted to add downstream processing as well, because we saw that as a real opportunity for our shareholders to be rewarded for the uplift in revenue. To that extent, we've got 3 projects on the go. We have our Maneri graphite project located in the southern part of Madagascar, and that's really at a pre-construction stage. And the second project is a downstream project, which is to produce expandable graphite. That's being done in joint venture in India, and that project itself is under construction and should be completed by the end of the year. And our last project is to produce battery anode material, which I'm sure we'll talk about a bit later on. And we're looking at a pre-feasibility study at the moment in collaboration with a US company called Urbix. So we're looking to produce that. And so the company's pretty busy.
Yes.
Clearly focused on graphite, international, and I think positions itself well in terms of the graphite industry globally.
Excellent. And I find very interesting the downstream. We will talk later on about supply chain. I think it's critical to cover all those elements in the supply chain within, the critical minerals space.
Absolutely.
This is our second series of the battery metals, where in the first episode we had a panel discussion. It was a very generic conversation about battery metals. Today we're going to cover, like I said at the beginning, graphite in more depth. Graphite, I don't think it gets enough attention sometimes. I think we're all talking about lithium and so on, but graphite, I think, is going to be as critical, if not more, as we will see later with the demand projections. So, Tom, can you give us a little bit of a simple understanding about what are battery metals and why are we essentially talking about them and about graphite in more specifically this time?
Sure. Look, battery metals generally refers to the key materials used in rechargeable batteries. This includes a fairly extensive list, the likes of lithium, nickel, cobalt, graphite, obviously, manganese, alumina, tantalum, tin, magnesium, vanadium, etc. So there's quite a long list in regards to what people refer to in terms of battery metals. The rapid uptake in terms of electric vehicles and battery-based energy storage systems around the world is really the thing that's driving demand for these lithium-ion batteries. Right now, electric vehicles and battery manufacturers are pretty nervous about the security of supply of raw material. And in this regards, they're hoping to certainly focus on what we're saying are battery metals, and all the way upstream as opposed to downstream, so to the mines, etc. Mm-hmm. And many of these, like graphite, have been classed by the world's biggest economies as critical. So there's a lot of focus. There's a lot of focus on them right now in terms of both availability and security of supply, both now and in the future.
Excellent. And in terms of graphite, why before graphite wasn't important, or we weren't talking so much, and now we identify as critical? I understand also that there is an impact on where is currently the supply chain of this graphite is coming from. I believe it's an 80% is coming from China at the moment. So that's kind of driving as well what we do the rest of the world.
Yeah. Look, graphite itself is an interesting commodity. Graphite's basically a crystalline form of natural carbon. And we're familiar with diamonds, we're familiar with coal. There's another type of carbon, and it consists of a number of layers. But the big thing with graphite is its unique, very, very attractive properties. It's incredibly light as a material. It's a great conductor. It's very, very strong, and it has a high resistance to temperature and corrosive environment. So, in essence, it's really a super material. And we've really only just started to flag that now. Historically, and it's been used for the last probably 500 years, graphite's been used in things such as pencils, but the main use has really been in the refractory and high temperature applications for production of things such as crucibles and kiln furniture, that sort of high temperature application. So unlike some of the things such as lithium, which has been a product in small demand, there's already been an established demand there. What happened in 2020 with lithium was that for the first time ever, lithium-ion batteries became the biggest consumer of lithium. And that's when the price really took off, because the demand really took off. And people started to get worried about supply. And that's what's happening right now. Groups such as Benchmark Minerals Intelligence are putting out that 2023 is a pivotal year for the reasons of it'll be the first year that lithium-ion batteries will be the biggest consumer of graphite, natural graphite. And you know, we've already seen graphite, and we've seen it in industry and the various uses, but it'll be the biggest producer. And the second reason is that there will be a material deficit starting in 2023, all the way to 2025, when it really gets quite serious. So that's kind of why the focus is now coming in on graphite. And there's no getting away from the point that 60 to 80 kilos of graphite goes into a lithium ion battery that goes into a vehicle, and that's much more than any of the other components that go into a lithium ion battery. So again, people are getting nervous about supply, and of course you mentioned before about the dominance of production. Let's face it, China is out there. It's producing the best part of 65 to 68% of the world's natural graphite at the moment. The world wants to diversify in terms of geopolitical risk on that matter. So they're looking for new opportunities geographically to solve that problem.
And for people that are not fully conversant on the topic, they will hear about a difference between natural graphite and synthetic graphite. Can Tom explain, please, the main two differences and why it's important to differentiate them?
Yeah, look, I mean, graphite itself comes in different forms. Natural graphite, that is. It comes into amorphous, vein, and obviously flake graphite, which people are probably more au fait with. And they have different uses, and so they have to qualify, etc. In terms of natural graphite versus synthetic graphite, synthetic graphite, as the name suggests, is fundamentally an artificial graphite. Which is made from needle coke, which is a byproduct, if you like, from the oil refineries, or pitch coke, which is sourced from coal. From an environmental perspective, this can raise concerns in regards to not only potential pollutants, but also the carbon footprint in the production of synthetic graphite, given the enormous amounts of energy required to produce the product. Having said that, it does, however, produce a very homogeneous and predictable product. Taking it up to 2,500 degrees will do that. Both natural graphite and synthetic graphite have distinctive benefits. in the production of specifically lithium-ion batteries. Natural graphite is generally cheaper to produce. As I said, it has a smaller carbon footprint, but it also allows for a higher capacity within the battery itself. Synthetic graphite, however, produces, or the introduction of synthetic into a battery provides for a faster charge and generally a greater battery life. So that's why they complement each other at the end of the day, and the industry blends the two graphites to ultimately produce an anode that goes into a lithium-ion battery.
Excellent. I'd like to talk about where does graphite, we talked about China a lot, and 80%, that figure that I gave before was about synthetic graphite, and then you complemented that with 68-70% of the natural graphite comes from China now. But where else? I understand Europe has a bit of production, or had in Ukraine or Central Asia with Russia there. And we experiencing some challenges in that area. But can you give us a bit of an overview of where else does graphite come from at the moment?
So, the Chinese I mentioned before, and you mentioned, largely dominate all aspects of the graphite supply chain, not just the production of natural graphite. But in terms of natural graphite, they produce the large majority of natural graphite supply. And while they'll continue to expand, and we've seen that already in certain specific areas, particularly in the northeast of China, Africa really looms as the second largest producer now and moving forward. So currently, if you look at the G7 nations, together with countries that the US has free trade agreements with, only 1% of the world's natural graphite comes from these areas. Basically, you're talking about the second largest producer, according to INN in a report that came out earlier this year, is Madagascar. Third is Mozambique. And between those two, they produce 20 to 25% of global production, and it's going to grow. So you couple that with the Chinese, and that's where the bulk of the graphite currently comes from. Other groups, other countries that currently produce, Canada, Brazil, some from Mexico, obviously some from Canada, Scandinavia as well. But if you look at maybe future supplies, you're talking about a fair amount of development going on in Canada, Brazil, Australia, as well as Scandinavia. But really outside of China, the future is Africa. And that means Madagascar, Mozambique, Tanzania, which isn't a current big producer but has a number of mines under development, and Namibia. And these are the areas where significant exploration has fundamentally already taken place.
Excellent. And we're talking about the raw material and the production of graphite, but before we were mentioning the supply chain and the challenges that come with that supply chain. So if we can please get a little bit of a scenario of, from the start to the beginning of the process of the graphite being incorporated in, or part of the graphite being in a car, for instance. Can you please navigate us through that journey?
It's big and it's complex, but if in looking at the supply chain from mine to battery, there are a number of steps. Obviously, the first one is the mine. And the mine itself needs to produce a tailored product suitable for use in lithium-ion batteries. And that means just because you produce graphite from a mine doesn't mean it can be sold into the battery market. It's got some very strict specification requirements set by buyers, and they relate to the physical and chemical characteristics of the material. And those are characteristics that a lot of them you can't change. So in some respects, what's in the ground predetermines what products that mine will be able to sell into. So if we talk about the battery market itself, for example, the graphite ore needs to be processed. So initially it's crushed and it's ground. It's put through a flotation circuit where the material is enriched from generally single-digit percent total graphitic carbon to a fixed carbon product of anything from probably 92 to 97, 98%. And the higher the grade, the higher the premium that you get for that product when you're selling it. The technology itself is nothing new. It's a 100-year-old technology. I think the know-how is in the experience applied to the mine to make sure that the process plant produces to the strict specifications required for the battery industry, and that's absolutely paramount. There are a number of new other process routes being trialled at the moment around the world, but the process route I outlined is pretty well the stock standard process route. So the product itself comes out, and it's, as I said, for batteries, it's generally a finer material, finer flake material, generally in the order of 95% fixed carbon plus, but it's also got to meet other specifications, and that's the bulk density of the material, the moisture content, the ash content, as well as the analysis of what remains as impurities in the concentrate, given the sensitivities around anode chemistry. So that's the concentrate that comes out of the mine. It then goes through a second stage, which is really a sizing, shaping, purification stage, which then goes through a coating stage. I put it in that kind of order, even though some people may have understand it as coated, spheronized, purified graphite. So you need to mill it so that basically the size is reduced to a fairly uniform size. It is then tumbled, for want of a better phrase, to create a little ball of graphite interlocking with other pieces of graphite on a microscopic scale. It's then purified, and there's a number of purification routes. There's thermal and chemical, as well as a few others. And then it has a special coating applied. And that process itself is technology based. So if anybody looking to get into that realm, which is currently dominated by the Chinese, needs to understand that they need to obtain access to a technology or spend a lot of time developing that technology. So again, that's a way that the market will be slowed in some respect moving forward. The Chinese, incidentally, produce around about 100% of coated spheronized purified graphite. So anyone listening to this discussion today with a lithium-ion battery, and I assume that's probably the bulk of the listeners easily, have had that graphite go through China at one stage. And it's not that it's China, it's just that it's dominated by one party. So the global market is weary of one area dominating such an important part. So that's the coated spheronized purified graphite, and that's an intermediate product between the concentrate and the anode. So that coated SPG product then gets mixed with synthetic graphite, and it's combined to produce the anode that it's sent to the gigafactories for production of the electric or the lithium-ion battery that goes into an electric vehicle.
And I understand that the battery manufacturers today are also, names like Panasonic or LG Chem in Korea, Panasonic in Japan, BYDs in China, and Foxconn, just to name some of them, are in Taiwan. So I think that is already also there's a problem there with the battery manufacturers, and what are the rest of the world is doing about this type of solidification of the battery manufacturers being in one territory only. Do we see any movement there in Europe and other areas?
We do. Basically, the battery manufacturers, if their target audience is the automotive manufacturers, then they need to be close, because minimising transport of batteries is one of the key factors in terms of working together. Panasonic, for example, is located inside Tesla's factory. So the battery producers are going to be in close proximity to car manufacturers, and car manufacturers means the US, Japan, Korea, China, India, and Europe, broadly speaking. So that's where we're going to see, and that's where we are seeing these gigafactories being built. And in line with that, so that's a lot of cases. That's where we're seeing the anode factories being built as well to supply those. What's been forgotten about is the upstream part of the business. The funds, trillions of dollars, have gone into the car manufacturers building new factories or changing assembly lines to suit lithium-ion batteries, and that's why I believe the current makeup of lithium-ion batteries will stay the same for quite a few decades. So the issue is that the funding's gone into there because the demand's been there for electric vehicles, but people have somewhat forgotten about upstream, and that's why, as a company, Evion is focused on the two areas, which is the mine and the coated SPG line, because it's largely been forgotten. And one of the places we're looking at is Europe, and that places us right in the middle of car and gigafactory central, and so it makes sense to do that. You can never move a mine, but where you want to do downstream, in pretty well all the cases, particularly in coated SPG and anode production, you want to be near cheap power. So you want to have that access. You want to be in a secure place, and you want to be close to your end users. So I think moving forward, that's what you're going to see. The mines will supply graphite concentrate to initially CSPG plants, which will be located near anode plants, which will be located near gigafactories, which will be located near the auto manufacturers, because it makes sense from a political stability point of view, a diversity point of view, a power cost point of view, and where your end user is.
Mm-hmm. You said a key thing. I think there are a lot of the attention, including the other day I was watching Elon Musk. I think it was giving like a bit of a conference, and I don't know all the details, but it kind of implied in his response that the bottleneck is in the downstream. He doesn't believe that is upstream, but I think that's either Elon is hiding something, or we forget how long does it take to put a mine to production.
Maybe he hasn't quite bought into the investment opportunities yet. I'm not sure, but look, I mean, at the end of the day, I'm obviously talking with downstream producers all the time, and they keep telling me it's becoming more frequent that their concern is risk of raw material supply. It takes a long time to get a mine up and running. We're running as hard as what we can. We put our first drill hole down in 2018, and our project is now in pre-construction phase. So we've moved as fast as we possibly can, but typically you're talking about a 10-year period needed to get into production. Coupled that with the qualification periods, interestingly enough, we have seen of late that some of the qualification expectations which were in place a few years ago, which was like provide us with 2 to 5 tonnes of concentrate material and give us a reasonable amount of time, and we will see if you qualify, ultimately, is now being dropped in terms of smaller quantities and shorter timeframes because of that sense of urgency that we're seeing downstream. So I think they get it. We've seen it being translated into the lithium mining industry in terms of the prices that and the market capitalizations that they operate in. We did see a similar thing with nickel about just over 12 months ago. We saw it in cobalt in 2016. And for all the reasons I've mentioned to date is I believe that 2023 you'll see a significant shift, understanding and an appreciation of the importance of graphite to that supply chain and the implications of or the impact of deficits starting to mount and competing interests for the same product should see a renewed interest in graphite and perhaps some investment returning to that area.
Excellent. And I understand that Evion Group has achieved some key milestones recently. So what has been achieved and what's next for you guys?
Well, we made two announcements this week alone. The first one was the opening up of a school, a primary school in the area, to children who historically didn't receive an education. So we see that as a pretty important um, landmark in some respect in our relationship with the local communities. It'll cater for 100 kids. It's fairly basic, but there'll be 3 teachers in 3 classrooms, at least teaching these kids numeracy and literacy at a basic level, and that provides these kids an opportunity to um, perhaps consider other options in life apart from subsistence farming. And perhaps trade opportunities, welding, boiler making, whatever, or even beyond that into university if they move into one of the bigger cities. So we're pretty proud about that. We've already furnished one school a few years ago, which is about the best part of 6 kilometres away. We've also assisted with an Australian non-for-profit company called Australian Doctors for Africa. We helped finance and we helped the management of the construction of a medical facility nearby. And also within the announcement was the donation that we made as a food parcel to each of the 5 villages around the area, because it's actually gone 180. There was about 3 years of total drought. The locals had no ability to grow food. We went in there and we have provided some water pumps, but it's clearly not enough. It's for agricultural needs, and the weather continues to be dry. So we've donated something like 30 tonnes of food so far over the last few years. But as dry as it was in November up until 3 weeks ago, they had torrential rains. So it turned the whole place upside down, and so that's the reason we provide food as well recently. So working closely with the communities is important. They're part of our future employment work pool, and they were there first, so we need to recognise that and look after them. The other announcement we made was the completion of the environmental social impact assessment, so linked to some degree, undertaken by independent consultants, being Resolve Consulting. And they came back highlighting no red flags, that basically the mine can be developed in a safe way, in a responsible way, with a minimum environmental impact on the ground. So we're not talking about a huge mine, low strip ratio, processing about 500,000 tonnes a year. So it's not going to be a large iron ore or copper porphyry. The impact will have minimal impact on the surrounding area. As part of the DFS we completed late last year, we engaged Golder out of South Africa, obviously an international company, to do water testing, the water coming from underground aquifers. And we did pump testing over a reasonable period of time, and they were able to model that and show that the water requirements for the plant won't have any impact on the surrounding area. So they're the sort of things we're doing at the moment. To make sure that as we move in a mechanical sense, a technical sense, a financial sense in the development of the mine, that we're cognizant of our responsibility from an ESG point of view, that we have people living there, and that we have a responsibility to ensure that they're looked after, and socially and culturally they're happy with our path forward.
Excellent, really good news. I'm excited to see what's coming next from you guys. And if you allow me a little comment, I had the pleasure to work with some of the companies in Madagascar, and I've seen the positive impact in the careers of the people. I'm a HR expert, so I always focus in those areas, and I've seen people coming from the villages around the mine site that were provided a basic primary education, and as they've grown, they had tertiary education, they were employed by the company, and to the point that they were had a bachelor's degree, and they were ready to work internationally, and they were very skillful, and they were in a good demand, so they had great experiences working outside of Madagascar in the end.
Well, we're certainly blessed with Madagascar being a producer and exporter of graphite for the last 100 years. It means that there's a pool of geologists, mining engineers, metallurgists with graphite skills. By bringing those people to the local area, we'll be able to teach over the medium, long term, the local people just a little bit about the operating know-how, whether it's in the pit, whether it's outside on the exploration side, or on the plant itself from an operations point of view. So they will certainly be uplifted. We all know globally that for every one job that's created, there's about 6 or 7 created indirectly to support the people and the mine site itself. So that's going to be really positive. We have one of our geologists. We brought him over a couple of years ago. He was under scholarship with the Australian government, and we provided additional financial support for him to do a master's here at Curtin University in Perth. He topped the class across all students, and consequently was asked if he would like to do a PhD. So we're funding him during that process, and we're extremely proud of his achievements. And that's the sort of thing that can come out of these opportunities: international experience, higher education, and then going back and giving back to the local population. And everybody's a winner. We'll put in funds for the development of other industries which perhaps support us. We're looking at the potential to develop a nursery nearby, whereby they can sell us and look after rehabilitation in the area, and also a number of handicrafts that can get sold internationally, etc. So it doesn't have to be directly with the mine, but so we're keen to expand the opportunities for the people in the area.
Very good stories those are, Tom. Tom, let's get the crystal ball out there. What's the future like for the graphite industry?
Well, it's an interesting one, because the current, up until recently, the biggest consumer of graphite on the small fine material side was the refractories industry, which had a direct link to metal production, global metal production. And of course, that has a direct correlation with global GDP. We've all seen, because of COVID and recently global inflation, etc., that's dropped. But the battery industry has taken the opportunity to soak up what hasn't been consumed by that industry. And yet we're still destined, according to benchmark, to hit a deficit by the end of this year, and a significant one by the end of 2025. All we need to do is for global GDP to pick up, and then there'll be competing interest for that material, and it'll be even a more interesting situation as two industries compete for the same material. So that's the first thing. There's a great pictorial illustration that was generated by Benchmark Minerals late last year, I think it was. It shows that the number of new graphite mines required to be up and running by 2035 is nearly 100 new mines. They also commented by 2025, which is not that far away, that 25 new mines will be required to meet that demand. And this is a huge order. And I'd be struggling to identify that many new mines that have the potential to come on stream. So I think it bodes well if you're a developer or an investor within the natural graphite space. Fortunately, as much graphite that goes into, say, an electric vehicle, the cost is not high. And so natural graphite could literally double in price, and it wouldn't have a material impact on the price of an electric vehicle. Mm-hmm. But you can imagine what it would do for the investors within producers and developers of natural graphite. So I think it looks really positive for all concerned in the natural graphite space. People may have to wait a little bit longer for their electric vehicle, but it will draw attention.
Been waiting for 12 months.
Yeah, absolutely. So It's an interesting scenario. People are committed now to the change to electric vehicles incorporating lithium-ion batteries. I think the current global production of graphite, natural graphite, is about 1.2 to 1.3 million tonnes. The expectation is by 2035 that number's going to be 7 million tonnes. So that's a massive uplift. That's a lot of extra tonnes and an appreciable increase from our current position. And you can only deduce that this provides current developers an enormous opportunity. So it looks good. The price has got room to move up without being a material impediment to the cost of an electric vehicle. So I think more people will understand that, and more people will start to investigate natural graphite opportunities globally.
Yeah, I think, and the society in general, they making more of an effort to understand where things come from, and just making sure that ethical bias, I think they call it. So it's important that people like Evion, we were talking about all the successful stories and all the investments you're making in the communities, and the social impact that will have in the areas of impact of your project. So people need to understand, where is it coming from? You get your new car that you've been waiting for a long time, but where does it come from, and why is it important to recognize that?
Yeah, transparency of supply chain is going to be a key issue moving forward, and the world still needs to get their head around that, and that brings with a whole new set of issues as well. And we've seen the US Inflation Reduction Act and other acts, current and no doubt in the future. The European Union recently announced their own act. So that's one of the things we're going to see in the future. And that will demand transparency of supply chain, which is obviously an important issue. Another issue will be, I think, the geopolitical risk issue. As I said earlier, the future of natural graphite really on the short to medium term is Africa, without a shadow of a doubt. But we need to understand that geopolitically we saw what the world's already seen what happened in one major region, and when it dominates energy supply, and we remember what happened in the Middle East in the 1970s. And the result was basically a worldwide recession. So dominance by one particular region is not a good thing. There's also the risk of nationalisation, and we saw that in Tanzania, I think it was 2017. And whilst the mines had a bit of a hiccup and then they're moving again forward, the world can not afford a hiccup like that, especially as it heads towards the deficit side of things. But I think the biggest issue moving forward is going to be finance, project finance. If graphite miners are not being supported by way of the equity markets, they'll find it hard to raise the necessary funds to develop the mines. And we've seen some interest from car manufacturers and other upstream organisations paying close attention to lithium projects. Some graphite have had some noises cast in front of them recently, which is positive. But we need to see a change in attitude. So that at the moment, I believe there's a chasm between the end users who appreciate the risks that are currently out there in regards to graphite, but we're not seeing it from the investment community. I have noticed over the last probably 12, 18 months that investors are now saying, well, I don't know about graphite, I believe there's plenty of it, etc. Just saying graphite is pretty important to the future of decarbonisation, but I'm not sure that now is the time to invest. So at least there's a recognition of the importance. I believe by the end of the year that will change, and we'll start to see greater focus being brought on graphite developers, and that should allow for financing of advanced projects to go through construction and into operations.
So I think, Tom, I'm gonna have to invite you in a few months' time and see where our position is, and to talk a little bit more about the funding that we didn't really have a lot of time today to cover. But for now, Tom, I just need to say thank you so much for being with us today.
Really appreciate the opportunity. Thank you.